Last panel, come on up, you guys. Because I get to run this thing, I told my panelists, let's just get rid of that topic. I want you to just show me stuff. Show me what you can do. This is not theoretical, right? Right? A lot of you have been working like crazy on this because Brewster said, hey, could you make like a website that is distributed? Could you make like a Dropbox that's distributed? He set all these crazy challenges. So let's see what you came up with. All right, so we call this the Moonshot Challenge, but we're really talking about interoperability, and we wanted to give it some kind of tangible goal so that you wouldn't talk about interoperability, but you would show us what you can do together. So we're still going to ask you to do that. Let me introduce you to each of my panelists. They're great guys. I've come to know them quite well over the last few months. The first is Juan Benet. Now, Juan Benet is the founder of IPFS, and I think of Juan as being kind of like the Johnny Appleseed of the decentralized web. I mean, he is everywhere. You know, he's dropping seeds here, he's dropping in there, he's talking to Vint, he's talking to Brewster, he's all over the world. I don't know how this man sleeps, but he has done a fantastic job, and when you talk to people, many people are building on top of the protocol IPFS. Juan, tell us in 3 sentences or less what IPFS is. What does it stand for, in fact?
IPFS stands for the Interplanetary File System, and the goal is to make the web capable of working across planets, which is a tall order when you think about how the web works today. The point is to think about websites as divorced from location, as being content addressed or addressed by public key, so that we can move around the content from one host to another and load it there as if it was local. We take a lot of constraints, like making sure that our stuff works for developing world, where people don't have very great connectivity, where latency is bad, bandwidth is terrible, and so on. We care a lot about making sure the web is decentralized in terms of control, so that website creators can build their stuff and push it out to the network, but users retain control of their data. And users retain control of the ability to use applications. We see software as a superpower of granting other people superpowers. And when you give somebody else a superpower that's locked up to some location, if they can't access that location, then that superpower isn't very good. So we really care about lifting the web from its location.
Well, thank you. You have dedicated your life to that. The next panelist is Trent McConaghy. Trent started as kind of a chip developer. He had a very successful career in that. And then I think Trent McConaghy, and he's written several books. And when his books sell for $100, Trent gets how much? $1. And Springer, his publisher, gets $99. And yet, he's eager to keep perpetuating this scholarly publishing model because that's the way it works. Tell me in 3 sentences what IPDB stands for and BigchainDB.
Sure. So actually, it started with, we saw our artist friends creating amazing digital art, not getting paid, hardly able to feed their families. And we started with the question, could you own digital art the way you own Bitcoin? Because if collectors can collect digital art somehow and have provenance, then our friends can feed their families. And we pulled on that thread. It worked, it worked, it worked. We built out this project called Describe. I'll show it later. And then we ran into a problem. As more and more people were using it and larger sites wanted to use it, there was a scale challenge. It was brought up earlier today. I was trying to bug a bunch of friends to draw on scale to figure out how to scale things up. Many people are working on it. We said, well, there's already these amazing technologies out there that scale incredibly well. Let's leverage them, distributed databases that are centralized, and let's figure out how to decentralize them. So we did that. That became BigchainDB. It's a decentralized database at scale. And then we said, now that we have this software, let's make a public version of this that we can roll out to the planet for anyone, anywhere. And that is IPDB, Interplanetary Database. It's meant to sit side by side with IPFS, the file system and the database. They have a shared data format. which is IPLD and amazing. So kudos to Juan for that effort. And overall, that's what we've been rolling out. So IPDB is really this database for the planet with global consistency of your data that anyone can see, anyone can use.
Okay, so let me get this straight. You have the Interplanetary File System, you have the Interplanetary Database, and now you have the Interplanetary Link data.
Yeah, so they have the common data format, and what that means is basically the walls among these different ways of storing data are permeable. So you can have this chunk of data and it can just kind of flow around. It can be living in IPFS, it can be living in IPDB, it can be living in DAT, anywhere you want, and it doesn't matter, it's just there. And that's highly exciting.
Go to Evan Schwartz. Evan went to Brown University, coded, and but what he's really interested in, he told me, is the future of money. So somehow this big amalgamation of political science and fascination with money and coding led him to Interledger. Tell me what Interledger is about.
Sure. So Interledger is an internet protocol for money. And so a lot of people in this conference have talked about adding incentives to things, adding compensation to things. We've talked a lot about how do we add compensation to the decentralized web? How do we get people to use it? So Interledger is a protocol for doing payments across different networks. And the way that we look at it is all different payment networks we think of as ledgers. So Bitcoin is a payment network. You can pick any of your favorite digital wallet that's a payment network or a ledger. Ethereum is a ledger. All of these are different ledgers. And the problem today is that if we want to build payments into something, we basically have to pick one or pick many. But ultimately, the sender and the recipient have to be on the same network in order for this to work, which is terrible. This is why when you go to pay for something, you see all these myriad options. But this problem has already been solved for information. It was the internet. The internet is a protocol for routing packets of data across disparate networks. And so this is what Interledger is doing for money. It's about routing packets of money across different networks, whether they are blockchains or other types of ledgers. And what's exciting about that is that lets you build payments into your other kinds of protocols in a way that is completely agnostic to what ledger it's actually using.
Thank you, Evan. Next is Denis Nazarov to address that problem through Mediachain. Denis, tell me about Mediachain.
Thank you, Wendy. So Mediachain is an open universal media library, and it enables participants to collaboratively describe creative works in a decentralized system. And the goal of Mediachain is to connect creators directly to audiences through content itself. So today, an image can easily go viral on the internet and millions of people will see it, but it's very hard to know who actually made that piece of content and to connect to the creator directly. Mediachain empowers developers and creators with technology similar to Shazam and Google reverse image search to resolve to metadata about creative works in a decentralized network.
So let me get this straight, Denis. Vint Cerf writes many articles. He's an entity, and he's connected through Mediachain to his co-writers and through many different articles that he's written. And this is somehow immutable because of what Mediachain does?
Yeah, I think a paper is a great example of a complex bundle that an entity that references that consists of many other entities. And Mediachain will allow to basically cryptographically link these entities together in this collaborative system where the paper could start with referencing Vint or other participants or anything he references in this dynamic way, but also enabled for people in the future to verify his results, annotate it, extend it, etc.
Great, thank you very much, Denis. And finally, Karissa McKelvey, about the DAT project.
Yeah, I got really excited about DAT when I met Max in Oakland over coffee one day. And he was like, "You're awesome. Let's just work together right now. Let's figure out how to do it." And one of the things that excited me the most was his focus on government data and opening government data, because I got my work in political science and computer science, and I was trying to fuse those. And for me, the most important part about DAT is that we can decentralize data in the way that universities and research labs are already decentralized. They're just not decentralized in the way that they should be in terms of their data storage and bandwidth. And so we can help people by being able to share their data in a peer-to-peer fashion that can also be updated and checkpointed just like Git. So scientists can reference their data in a future-proof way in a content addressable hash.
Okay, let's stop there because I think you lost half of our audience. Is what you're really saying that when you were your PhD candidate, right? You had data sets, you had code, you
Yep.
had text,
Yep.
and you wanted to share that maybe within your research group, but maybe one of your researchers was at Cal and one of them was at Oxford, and somehow using the decentralized web, using a hash that was immutable, you would be able to do that better. Is that what you're saying?
Right, so when we're collaborating on data, we're actually reproducing people's research. So whether that person's in my lab or if that person's across the globe 10 years later, I should be able to reproduce my research and reference the data in the exact same way, even if the same server goes down, right? So if the data moves to a different server with a different HTTP link, I should be able to still reference that data.
Right.
Does that make sense?
Right, that makes perfect sense. Okay, so we have a protocol, we have a database, we have money going in every kind of currency, we have metadata, and we have data sets. And you're all working in decentralized ways. And if you could all come together, we'd have the whole package in a way, right?